All right, number 6 says, in how many ways can 5 players be chosen as starters for a basketball team if there are 11 players and it doesn't matter what position they play? So basically we have 11 players and we're just picking 5 of them and we don't care about the order. And if we don't care about the order, that's the combination of 11 choose 5. You could use the formula, which is n factorial over n minus r factorial times r factorial. You could do that. If you have a calculator, I'm okay if you show that as your work. And remember, on the graphing calculator, you can just go to the math button and you can go to the probability option. Combination is one of your choices. Now, I forgot to put my 11 in. So it's 11, then we go to the math button, then probability, and we want the combination here. It's going to be 11 choose 5. And it's going to end up being 462 different ways that they can pick that lineup. All right. For part B, it says they're doing a starting lineup, but in basketball, you might be aware they have usually 1 center, 2 forwards, and 2 guards are the 5 players. Now, if you get real technical, there are different kinds of forwards and guards. We're not messing with that. We're just saying any 2 forwards, we don't care what type of forward. Any 2 guards, we don't care what type of guard. We want 1 center. So we're trying to choose 1 of the 3 centers. Common sense says you can do that 3 different ways. And 2 of the 5 forwards means we're going to be multiplying by that amount, fundamental counting principle, and we're going to be choosing 2 of the guards. And again, since it doesn't specify that there are different types of forwards or guards, we don't care about the order within that group of forwards or within that group of guards, which means it's going to be a combination. So technically, we have 3 centers. We want to pick 1 of them. We don't care about the order. That's a combination of 3 choose 1. And multiply. We have, oops, let's see if I can get this back. This is great video, huh? Ah, there we go. Okay. There are 5 forwards. We want to choose 2, so that's a combination of 5 choose 2. And then finally, there are 4 guards, and we want to choose 2 of them. And so we have that here. So this is going to be 3. Again, it's an and, so we're multiplying. 5 choose 2, I believe that is 10, if you work that out. And 4 choose 2, I believe, is 6, if you work that out. And so, anyway, it's going to be 180 different lineups, basically, or 180 different ways we can pick the lineup. All right. Moving on to our next question here. We'll scroll a little bit. Number 7 says, how many schedules can Daryl create if he has 10 classes to choose from and can only take 6? Now, we're talking about a school schedule here, so you probably care about what your first period class is, what your second period is, and so on. This person apparently has a 6-class schedule, and there are 10 to choose from. So there are 10 ways you could pick your first period class, 9 ways you can pick second period, 8, 7, 6, 5. Okay, and you can multiply that out. Order matters, so that's a permutation. Taking 10 things, we're choosing 6. Okay, so you could also use the permutations formula. It's n factorial, which would be 10 factorial, over n minus r factorial, which is 4 factorial. If you work it out, you're going to get the same thing as up here. And, you know, nothing wrong. You can stick it in a calculator as well. Personally, I like to use formulas as little as I can if I understand how to do the problem. I think that's a little bit more effective and less memorizing, right? So if I've typed this into my calculator correctly, it's a big number. It's going to be 151,200 schedules that this student could make. And it says, how many ways could he select his classes if order isn't a factor? So in other words, if we don't care about which class is first and which is second, if we just care what 6 classes he has, that would make it a combination. That's the combination of 10 choose 6. And again, if you wanted to work that out, that'd be 10 factorial over 4 factorial, 6 factorial, or you can stick that in the graphing calculator and you can get an answer to that pretty quickly. It's going to be 10 choose 6, and that's going to be 210 schedules. So if we're not including order, not nearly as many options. All right. Question 8. Trent's making a pizza. He'd like to have 3 vegetable toppings, 2 meat toppings. We want pizzas. He wants to choose from 5 different vegetables. So he's choosing 3 vegetables from a group of 5, and he's choosing 2 meats from a group of 3 meats. And we're not like stacking these on top of each other or anything like that. They're just kind of mixed on top. So this implies that order should not matter, which means we are doing combinations. So we want meats, and again, there are 3 meats, and we want to choose 2 of them. So that's going to be a combination of 3 choose 2, and multiply. There are 5 vegetables, and we want to choose 3, and that's going to be a combination of 5 choose 3. So a combination of 3 choose 2 works out to be 3, because you're just leaving 1 out each time. And 5 choose 3 ends up being 10, and so there are basically 30 different pizzas that could be created.